you. It's an honor to be here. Um, so, I've been asked tonight to share some of my knowledge about AI and machine learning in order to have some background to the AlphaGo movie. And so, I sense that maybe most of you guys are Go players and are more interested in the gaming aspects. But I hope that I can shed some light on maybe how AlphaGo could do what it could do against Lee. And so I think that the way I want to start is by telling you that there is a massive schism in the academic artificial intelligence community. And understanding why that schism exists is probably the best way to contextualize what you're going to see tonight in this film. But first, I want to admit two things. The first thing is that I don't actually know Go. So thanks to Ed, I got a crash course in Go out in the lobby. So this is the first time that I've actually learned Go. And the second is I actually have not watched the film tonight. I wanted to experience it all with you as well. However, I am excited to see it, particularly because of the very provocative trailer. Did anyone see the trailer for this movie? A few of you? Well, in the trailer, which is extremely exciting and dramatic, it ends with a voiceover. These ideas that are driving AlphaGo are going to drive our future. And this is voiced over two images, one after the other. The first is of a young girl standing on her father's shoulders in the sunrise while the camera moves very rapidly. And then the second is of cameras flashing on Lee Sedol's face, who is clearly defeated and looking very defeated. Now, I think that hope and fear as emotions go hand in hand with all technological revolution. But I believe that the AI revolution is potentially more unique because it challenges our humanity not just physically, but also in our role of sapiens, the wisest of the animals. So, back to this schism. The schism actually gets to the heart of that. The schism revolves around the question of what is intelligence? What is intelligence? And from either an artificial or an organic perspective, I think that this question is in the heart of most modern research, whether it's zoology, computer science, psychology, biology, psychology, theology, any of the other ologies. This is really what is at the heart of a lot of research. But from the computer science, I'm a computer scientist, and from the computer science perspective, the schism revolves around one of two definitions. So the first definition, or the first side of the schism, is proponents of the dictionary definition of intelligence, the ability to acquire and apply knowledge and skills. On the other side is a more humanist perspective, the ability to think, reason, and understand instead of doing things automatically or by instinct. So I'm going to go on to talk about machine learning, but what I hope as you are watching this film is that you critically assess AlphaGo to discover if it meets one of these definitions, both of these definitions, or neither of those definitions of intelligence. I think that's probably the most critical thing we can do as you know, people who enjoy science, people who enjoy board games, and people who enjoy film. And that's what I hope that you guys can do. But both of these definitions imply one very important trait of intelligence, the ability to learn. Whoops. So, in its core, AlphaGo is essentially a learning machine. And there are actually two versions of that. So, tonight we're going to hear about the first version of AlphaGo, which learned by watching humans, both amateurs and professionals, play Go. There's actually a second version of AlphaGo called AlphaGo Zero that learned by playing itself and had no human input whatsoever. In both cases, AlphaGo utilized a technique called machine learning to acquire strategic knowledge in order to apply that strategic knowledge to beat a human at the board game. So I think that I'm here to answer this question. How do machines learn? How do they learn? When I teach at Georgetown to students, we define the machine learning problem numerically. And I apologize, this may get a little technical, but I promise I'll get out of this technical side as quickly as possible. So the numeric definition of the machine learning problem is that given a multi-valued array of numeric data, we're going to fit a model that optimizes by minimizing the error of a function that we're trying to solve. So this process of fitting a model, which is a numeric optimization problem, which is widely understood in mathematics, creates a set of internal parameters that that machine can then use to make decisions on new data, data that it hasn't seen before. And because of that ability to apply what it's learned to create this internal parameterization on new things, we say that the machine has learned from data, and it can make decisions and operate in the environment based on what is learned. That was a little technical, I understand. My students will ask me a follow-up question because that's great, but how do you create machine learning solutions? That's what they're there to learn after all. So probably an easier way to say it is that machines learn from example. And we need good examples in order to train machine learning algorithms. And those examples must be numbers. So the sort of practical side of things is what we're actually doing is we're creating a table of data where our rows are what we call instances in machine learning parlance or examples, and the columns are the features. They are the numeric properties that describe the world in a way that the machine can learn from. Additionally, we need one other component, and that's the ability to determine what error is, right? What does it mean to go wrong when you learn about the world? And so you can either do that by having the right answers ahead of time and then comparing how different the machine's answer is to the right answer. Or you can have a more reinforcing version of learning where the machine tries things based on its decision making and sees if that fails or succeeds. So those are the two mechanisms by which we detect error.